Kalashnikov was a renowned engineer and firearms designer from the former Soviet Union.
He invented the world's most produced rifle, the AK-47.
The bullets it fires can easily penetrate a 10 mm thick steel plate. But what you might not know is that this powerful bullet weighs less than 8 grams. Its destructive power comes from its speed, which reaches 718 meters per second. This shows that if the speed is high enough, even a very light object can cause significant damage. And an atom, like a hydrogen atom, is even lighter, weighing only 0.0000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000 can penetrate steel plates because the kinetic energy pushes the atoms in the steel aside, creating a hole. In this process, no atoms are annihilated or destroyed, showing that 718 meters per second isn't fast enough to break atoms. However, we know that atomic bombs can explode due to uncontrolled chain reactions. In this process, neutrons hit atomic nuclei, unleashing huge energy and creating more neutrons. What speed must the initial neutron have to break the atomic nucleus? Does it need to be close to light speed? Neutrons that can cause nuclear fission are called thermal neutrons. In fact, their speed is only 2,190 meters per second. Does it seem like you could trigger nuclear fission with just a bit more effort in your clap? Actually, you can't. Iron atoms are the most resistant to fission or fusion in the periodic table. This is because their nuclei have the highest binding energy. Larger nuclei undergo fission, while your palms are made of elements like oxygen, carbon, and hydrogen. Their nuclei are smaller than iron atoms, so they are more prone to nuclear fusion than fission when collided at high speeds. So, how quickly must you clap your hands to initiate nuclear fusion? Data from the Institute of Plasma Physics, Chinese Academy of Sciences, indicates the speed at which two nuclei must collide for fusion is over 1 million meters per second, or 0.3% of the speed of light. So, if you could clap your hands at over 0.3% of the speed of light, you might trigger nuclear fusion. However, 0.3% of light speed still falls short. The U-70 proton synchrotron in Serpukhov, Russia, was the largest particle accelerator in the former Soviet Union. In just 9 seconds, it can accelerate particles to almost light speed. In 1978, physicist Anatoly Bugorsky was maintaining the U-70 when he was accidentally hit by a particle beam that entered the back of his head, traveled through his middle ear, and exited through his left nostril, then exited from the left nostril. Fortunately, the beam had a narrow cross-section and contained fewer particles, so he survived. Moreover, his intelligence was not affected, though the facial nerves were damaged, causing paralysis on the left side of his face. But with millions of particles in a high-energy beam, what damage can just one particle do? Actually, countless particles in the universe travel close to light speed. Outside the atmosphere, an atomic nucleus moving at 99% light speed would pass through a fingernail-sized area every second. These particles, called cosmic rays, come from far-off supernovae and supermassive black holes in galaxy centers. Even if two particles are traveling close to the speed of light, their energy levels can vary greatly. Humans can accelerate particles to a maximum of 99.999991% of the speed of light. At this speed, the particle's energy is 280 times greater than one moving at 99.93% of light speed, and scientists have captured in space using detectors. These particles take away most of the omega particle's energy, leaving only a small amount to disrupt the body's atoms. However, the number of atoms in the human body is on the order of 10 to the power of 28. The number of atoms actually disrupted is so minuscule. The effect on the human body is barely noticeable. You might not feel a thing. But if the atoms hit you at light speed, everything changes. In relativity, as an object's speed nears the speed of light, its mass increases dramatically because the denominator in the equation becomes almost zero. Bigger than all the matter in the universe combined, this immense mass is packed into the tiny space of an atomic nucleus. It's akin to the moment before the Big Bang. You're not just hit by an atom, but by an entire new universe. So, relativity says nothing can go faster than light. But can we truly never surpass the speed of light? This is our Earth, don't blink, zoom. This is the Andromeda Galaxy, 2.5 million light-years from Earth. In a flash, your thoughts journey from Earth to Andromeda, 2.5 million light-years away. Zoom, 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 you could make the round trip multiple times in a second. The speed of light limits your body, but it can't limit your imagination.